Okay, this video is for revision for pressure. As you know, pressure will be tested in your WA3 up until barometer. Manometer will not be tested for WA3. Okay, manometer, which is actually your U-tube, will not be tested. Alright, not tested. But I'll still be going through this chapter just to make it complete. Now, first thing that we need to know for pressure is that the definition, it is a force acting per unit area. So please memorize this. Right. Then we have a following formula. P equals to F over A. You also need to know this. Now, P is your pressure, F is force in newtons, and A is area in meter square. Why do we need meter square? Because when pressure is in Pascal, this is the SI unit. Okay, so of course I can have the pressure expressed as Newton per cm square. Okay, I can have pressure expressed in kilonewton per km square, but these two will not be called Pascal. For Pascal, I need it to be newtons. That means your force must be in newtons and your area specifically in meter square, right? So a question may come out with an area of cm square. So for cm square, how do we convert it to meter square? We divide by 100 and divide by 100 again. Okay, so please see me if you need help with this. So this is the SI unit for pressure. 1 Pascal is the pressure produced when a force of 1 Newton is acting on an area of 1 meter square. Okay, so the pressure on an area depends on both the force applied and the surface area or the contact area, okay, on which the force is applied to. Hence, a force acting on a larger contact area will exert less pressure, as you can see from this relationship. Okay, so you need to memorize this. So we can try this question. This is in your notes as well. Now we have a cubic block. So if I were to draw out, okay, it looks like this. It is placed on a table such that one side of the block rests on the table. Now the pressure exerted by this block is P. Okay, what is the pressure exerted by the block on the table if the length of all sides are double? Sorry, I forgot to say something over here. Sometimes the question gives you mass, okay, and a lot of students like to put the mass as the force. They like to substitute in this formula, force over area. They like to substitute it as force. This is incorrect because mass is not force. How do we convert mass to force? Most likely it will be in terms of its weight. So remember this formula, W equals to mg. Okay, so always check that you are given force. If you are given mass, please convert it to a weight, and weight is actually a force. Okay, now this mass, in order to use this formula, make sure that it is given in kg, right? Mr. Lee likes to give it sometimes in grams to see whether you know how to convert. Okay, so why do I want to go through this? Because this kind of question, for this question, I may give you the mass of the cube. But because it was not mentioned, can I take it that it exerts a force of W? Okay, so this is the weight. The weight of the block, I assume it to be W. Okay, and one side of it, the area is A. So I have P equals to W over A. So this is for this simple block here. But now the question says, what if the length of all the sides are double? That means I'm going to have this block, right? And I'm going to have one more over here. So I double this length. But take note, I would also need to double the breadth. Okay, so I double, but the height I would also need to double. So with that, I should have from one block, it will become 8 blocks. Okay, one block will become 8 blocks. If not, you can if you don't understand, you can use Lego to try to build a block with all sides double. Alright, so because I have 8 blocks, now my weight is actually, the force that it exerts is actually 8W. Okay, but the area that is in contact with the floor, there are only 4 blocks at the bottom, so the area will be 4A. Okay, so what is the new pressure? New pressure will be 8W, which is the weight or the force exerted over the contact area on the table, and it will become 2W over A, right? So I call this the new weight lah, can? So it's 2 times W over A, and because the original was W over A, therefore the pressure will only be twice. Okay, so this part is about the contact pressure. Let's move on. How is pressure being used in our daily life? So this is a hydraulic press. Hydraulic press works by the principle that pressure is transmitted equally to all parts of the liquid. So over here I have actually a contact area A1 and contact area A2. Alright, so there will be a force of F2 and force of F1. Right, and since pressure is transmitted equally, this is important. Therefore, P1 will be equals to P2. Then when I have P1 equals to P2, then I can have this formula F1 over A1 equals to F2 over A2. So how will the questions be asked? Out of these 4 variables, F1, F2, A1 and A2, I will give you 3 of this. So your idea is to find the 4th one. That's a simple kind of question. Okay, so make sure you go through the questions in the notes. Then we quickly move on to density, because density was actually taught in Sec 1. Density is mass over volume, right? Density, the SI unit is kg per meter cube. Therefore, the mass must be in kg, then volume must be in meter cube. So just now I told you all, some people go for mass and they wrongly substitute as force. Okay, similarly, some students over here will use force and then substitute it as mass. Okay, mass and force, they are not the same. Alright. So SI unit for density is kg per meter cube. Okay, so we can also express it in grams per cm cube. So these are the 2 common kind of units for your density. But the SI unit for density is actually kg per meter cube. Okay, how do we convert from kg per meter cube to grams per cm cube? Okay, we have to divide by 1000. Okay, so memorize this, try it out. Then also, how is density being applied in our life? Okay, denser object will sink. Okay, I need to talk about this because sometimes I see students make the mistake by saying denser object will float. Denser definitely will sink. Alright, and also questions that they like to ask is, if I have this block and it has density of x, okay, this whole block, the density is x kg per meter cube. If I were to cut it in half, okay, what is the density of half of the block? It will still be x kg per meter cube. Okay, the x is just a random number variable, so the density will not change. So even if I have a ring, a gold ring, okay, a gold ring, and if I were to drill a hole, the density of the remaining gold ring will remain the same. So when will the density change? It is when I mix it with another object of different density. Okay, then I will need to apply average density. I need to find the individual mass, add it up to total mass, and individual volume, add it up to find total volume. Then I apply the same density formula, total mass over total volume. Okay. Next thing, we come to liquid pressure. Liquid pressure is given by this formula, rho GH or H rho G. Your P is given in Pascal. Your rho is density of the object. That's why we covered density just now. And SI unit of kg per meter cube. And G is your gravitational field strength of Newton per kg. Again, if we want it to be expressed in SI unit of Pascal, everything else must be in SI unit. That means your H must be SI unit of meters. Okay, so let us look at this question. An ideal mercury barometer are shown in the diagram below. What is the atmospheric pressure and what is the pressure at point X? Okay, so a barometer is used to measure atmospheric pressure. Okay, so I use capital P, then subscript ATM to show that it is atmospheric pressure. And if it's ideal, that means over here it must be vacuum. Okay, so they're asking for the atmospheric pressure. So in my lesson I told you all I have two things that I need you all to know. Firstly, if liquid surface is acted upon by gas or air pressure, you draw an arrow, draw downward arrow. Okay, so something like this. So what is actually acting on this liquid surface? It is actually our atmospheric pressure. Okay, I think drawing one will do. If not, you'll be very messy. How about here? Because this is vacuum, so there is no pressure. So although there's a liquid surface up here, alright, but I don't need to draw arrow. Okay. Second thing is I need you all to apply this thing called same liquid, same level, same pressure. That means if I have the same liquid at a certain same level, they will be subjected to the same pressure. Okay, so now they are asking us to find atmospheric pressure, PATM. Yes. Okay, but there's not enough information for us to calculate what's PATM, because PATM is actually the amount of air acting on the surface, right? So that's why they have to use a barometer to measure PATM. So first step, I'm done. If liquid surface is acted upon by gas or air pressure, I will draw a downward arrow. Okay, I drew a downward arrow and I denoted it to be PATM. Next, I need to apply this. Same liquid, same level, same pressure. So where do I have the same liquid, same level, and therefore same pressure? Just now I drew here. It's also PATM. It's very obvious, isn't it? Okay, how about here? Over here, it is also same liquid, same level, same pressure. Okay, for this surface here, the pressure is due to PATM, the amount of atmosphere. For this point here, where I apply same liquid, same level, same pressure, the pressure is due to the height of mercury acting on it. Right? Imagine this amount of mercury is acting on the point here. So the pressure, okay, is actually due to height of mercury acting on it, above the point, okay, and it's pressing down. Okay, and based on the numbers that are given, I can say that we have 860 minus 120, I have this height of mercury acting on it. So if I have this, recall the formula for liquid pressure is P equals to rho GH. Because we are using mercury, I can actually give you the mercury density 13600 kg per meter cube. Okay, so you ask, do I have to memorize this? No, you'll probably be given. Or if I were to ask you to find the density of an unknown liquid, then I need to give you P, G, and H. Okay, so you don't need to memorize any numbers for density. I know the G is 10, and I now know the height of liquid above it is 860 minus 120, but this is in mm. Okay, so I need to convert this to meters. So I will need to divide it by 1000. Okay, so I'm using the pressures formula for liquid. So it is pressure equals to rho GH. I need to give you the density of the liquid, which happens to be mercury. G, of course, is 10. And based on our same liquid, same level, same pressure, and by subtracting this height of 120, I can find the height of liquid above the point, the red color dot. Okay, so I can actually calculate P equals to a certain value. Let me do my calculation. Okay, so I have the value of 100,640 Pascal. Now, can this be left as 101? Okay, 3SF kilo Pascal. Also can, right? So this is the answer for A. So the atmospheric pressure is about 101 kilopascal, or 100,640 Pascal. Okay, so is there another way to represent this value? Okay, so another way to represent this value is by saying that it is 740 mm Hg. Okay, so let me explain this. 740 mm is actually the height. Okay, Hg is actually the chemical symbol for mercury. So by writing down Hg, it tells me that it is mercury that we are using, and if I know the density of mercury, I can just easily multiply with this 740 mm. But of course, the 740 mm, I need to convert it to SI unit of meters. Okay, but that's not difficult, right? What is actually missing from here? The G. The G is missing. Okay, but because everybody in our class stays on Earth, the G is the same for all of us. So in this case, we choose to omit the G. That means if I give you this 740 mm Hg and I tell you that this is atmospheric pressure, if I want you to calculate to Pascal, you just need to apply the formula. Okay, make sure everything is in SI unit, and remember to multiply by G. You should still get this value. Okay, but sometimes we don't need to actually explicitly calculate this value. So imagine now I go to another area and somebody tell me that the atmospheric pressure, or the pressure now, is 630 mm Hg. Okay, so 630 mm is definitely the height. Hg is mercury because we are still using the same liquid, and G is still missing from this expression, but we all know that the G is the same. So through the difference in height, H1 is less than H, therefore I know P1 will be less than P. Alternatively, if I go to another place and they tell me the P2 in this location is actually 800 mm Hg. Okay, so again, Hg is the mercury and 800 mm is actually the height. Okay, G again is not here. But if I were to compare H2 is now greater than H. Therefore, P2 will definitely be greater than P. So it gives a sensing very quickly, right, without calculation, that this pressure is higher than atmospheric pressure. This pressure is lower than atmospheric pressure. Okay. So this is just another way of expressing pressure. But if the question say calculate and leave your answer in Pascal, then you definitely need to apply this P equals to rho GH formula. And I remind you again, everything to be in SI unit. Okay, so if that's so, can I express answer of B as our mmHg? At B, they are asking for the pressure at point X. Yeah. So for point X, the height of liquid above it is 140 mm, right? So for B, the answer will just be 140 mm Hg. Okay. Okay. So that's all for what you will be tested. Okay. I will just continue with manometer. Okay, which actually is not difficult, but manometer will still need to apply these two concepts. Whenever we have a liquid surface acted upon by gas or air pressure, draw a downward arrow to indicate there's a pressure there, gas pressure or air pressure. Okay, secondly, you need to apply same liquid, same level, same pressure. Okay, so now let's take a look at this. Okay, so over here is listed as gas. So this surface is acted upon by this gas pressure. So I can put P gas. Okay, and over here is open to air, atmospheric pressure. So this will be PATM. Okay, so where after we done with step 1, every liquid surface that is subjected to a pressure, we draw the downward arrow. Next thing we need to do is find a liquid level that has the same liquid so that it will have the same pressure. So the obvious one will be here. Okay, so this is same liquid, same level, same pressure. Okay, so how do we do this? Over here, we start with the right hand side. The pressure is due to PATM. Okay, for the left hand side of this U tube or manometer, the pressure is due to P gas plus 10 cm H2O. Okay, how come I can leave it in 10 cm H2O? So again, just now this 10 cm tells me is the H. This H2O tells me I need to use density of water. But where's the G? Later on, if they do want us to express the answer in Pascal, then we need to multiply by G, change this to SI unit, and find out what is the density of water. So basically, U tube works this way. Okay, basically it's still same liquid, same level, same pressure. Therefore, P gas will then be equals to PATM minus 10 cm of H2O. Okay, this is actually the pressure due to the water. So we see that the side that has a higher liquid level is actually having a lower pressure, right? The right hand side has higher pressure, so it's able to push down the liquid upwards, okay, towards the left hand side. Okay, this is one of the questions in your notes. Let's see if we can apply this. So again, step 1, okay, draw arrows for surfaces, for liquid surface that is subjected to pressure. Okay, subjected to pressure. So I have this surface, okay, and it is due to the gas supply, so I put P gas. Okay, then over here is an open tube, so definitely it is PATM. Alright, so once we are done, we can go to the second step. same liquid, same level, same pressure. This is very useful. Okay, so please use this. But a lot of students, they like to miss out this one, and in the end they will miss out on some pressure, right? So where do we have the same liquid, same level, same pressure? Okay, so can I choose this point? Because they want us to express the pressure of the gas in meters of mercury using all this H, U, or V. U is this height, V is this height, H, it is atmospheric pressure. It is H meters of mercury. So can I put PATM equals to H Hg? Okay, so this is the height in meters. This tells me that I need to use density, but here density not given, is okay. And the G is also missing because it is just a short form. The G is the same for everyone. Okay, so this is atmospheric pressure. Now I need to find the pressure of the gas, P gas. Alright, so applying same liquid, same level, same pressure, this is the level that I need to apply. So over here, one side it is P gas, right? So I'm comparing, maybe I use a different color. I'm comparing this, the red color, which is P gas. Okay, it must be equal to the pressure at this point here. So the pressure over there is actually equals to PATM plus UHG. How do I get UHG? This is the height of liquid that is acting above this point, and this height of liquid is U. What is the liquid use? It is Hg. Alright, so now P gas is actually higher than atmospheric pressure, right? Because it's able to push the liquid upwards, right? So this is P gas, which we want to find. Now PATM, can I convert it to Hg, right? Because they tell us this, the atmospheric pressure is H meters of mercury. So we derive this from this information, plus UHG. Okay, so P gas is actually H plus UHG. That's all.